Okay, for this problem, it's about the kinetics problem. That's we consider the motion of the system in rectangular coordinate. Rectangular coordinates. It means that we consider this type of problem in XY coordinate system. That is the fixed coordinate system. That because we found that it may be better for set up the coordinate in XY, as the motion is in XY direction, right? Okay, so for this case, we have block A. Block A has a weight. Okay, now we have to review a little bit for the unit. Okay, for US customary unit, the base unit is weight. Weight is the base unit. Weight is the base unit. That is in pounds. Okay, but for SI unit, mass is the base unit. Okay, that is a little bit different. Okay, for the unit system. Okay, for US customary unit, we talking about the weight. Okay, is the base one. If you would like to find mass, okay, we have to divide it by G. That is for the US customary unit. G is 32.2 foot per second square. Okay, in different with the SI unit. For SI unit, mass is the base unit. Okay, mass is in kilogram. So when we would like to find weight, we have to multiply by G. So it's become Newton. Okay, do not confuse about this. Okay. And for this case, we have block B has a weight of 15 pounds. Okay, and the coefficient of static friction, mu F, is given is equal to 0.3, and kinetic friction is equal to 0.2. Okay, we would like to find the velocity of block A when it moves 1 foot to the right. Okay, and this is for the first question. The second one, if we replace the block A to be from just only 9 pounds to be 30 pounds, what's happened, and we would like to determine the gain for the motion of block A and block B. Okay, we would like to find the acceleration for that case. Okay, and both the block is released from rest. Okay, so let's consider first for the first thing that I would like to know, that for kinetics problem, the starting we have to start with drawing the free body diagram and draw the related reference line, reference point, to set up the positive sign convention to reduce our confusion. Okay, so for this case, we found out for this system, this point, okay, so I may set up it's like point O. Point O now is the fixed point for this system, right? Okay, so then it is better to set this point as the reference point, and after that we set the axis that is at this point, and from this is maybe the reference line for block A, and this is the reference line for block B. Okay, when we measure the position, that's the position that we would like to consider, we normally measure from the reference. Okay, so then it means that the positive sign convention of motion, or the positive sign convention for that kinematics, it just has to relate it to the reference point also. So for this case, block A, we measure from this line. Okay, so then to the left should be positive. Okay, to the left is the positive sign convention. And for block B, okay, we measure downward from the reference line. So then SB should be go down as the positive sign convention. Okay, so from this sense, okay, we may find the length that we set up to be the constraint. It's composed of this length, and also this length. Okay, if we consider this system, okay, the length chord is the constant. Is the if we combine these three parts, it become a constant length. Okay, that is control our motion. Okay, so then that's why we have this constant equation. From this constant equation, we take the first derivative to this equation, both sides. We get velocity equation. And we take the first derivative to this equation again, we get the acceleration rate. Okay, and from this equation, we can find the relationship of motion of block A and block B. And we found out acceleration of block A equal to minus 2 time acceleration of block B. What does this mean for negative sign? It means that if B goes down, A will goes up. Okay, and in the same manner, if B goes up, okay, A will go down. Okay, it's opposite. It makes it right. Oh, sorry. A will move to not go down. It's move to the if B goes down, okay, A will go to the left, go to the right. Okay, A will go to the right because we set up to the left as a positive one, right? Okay, and if B goes up, okay, A will move to the left. Okay, according to this. Okay, so for this case, if we from the problem we know that we would like to find the block A to the right, moving to the right of 1 foot. Okay, 1 foot like this. Okay, so then we know that if we just consider just only the magnitude of acceleration for A, the absolute value is just equal to 2AB. But which direction is depend on B goes up or B goes down. Okay, and after that, we consider the free body diagram for block A first. Okay. So for the free body diagram of block A, okay, if we assume that block A is moved to the right, okay, is moved to the right as a positive one. Okay, so then we set up move to the right as a positive. Okay, and free body diagrams become here. So if we assume it's moved to the right, okay, so then the friction force should be moved to the left because it is opposite to the motion. And when we cut the free body diagram, we find the tension from the table, and we have the normal force, and we have the weight. Okay, and on the right hand side, this is the kinetics diagram. Kinetic diagram is depend on the directions of the motion that we set up. For this case, we set up to the right as a positive, right? And so then MA is to the right. Okay, for this case, we may form the equation of motion. For the first, we consider the y direction first, that is summation Fy equal to MAy. But for this case, the block is stay on the floor, so it has no motion on in y direction. So then it's mean that Ay is become 0. So then for the direction of y, this is equilibrium, and we found that normal force become 9 pounds. And for this case, we go to check the maximum static friction and kinetic friction. Okay, so for the maximum static friction, if for this case, if normal force is become 9, we have the maximum static friction become 2.7 pounds. And for the kinetic friction is equal to 1.8 pounds. Okay, and For this case, if we assume that the block A is maybe have the sliding for the sliding case, so we assume that it should have the force tension is maybe greater than 1.1. The tensions may be greater than 2.7. This is just for the assumption. Okay, that is the will induce the block A to have a motion to the right. Okay, so for that case, this is just the case one. We assume that the tension is greater than 2.7. Okay, and the block A has a motion. So then the friction that we use, we have to use the kinetic friction that has the motion already. And from the free body diagram, kinetic diagram, we have the equation of motion for x direction to be t minus 1.8. 1.8 is the kinetic friction, and this is mass. Mass is equal to weight divided by g. Okay, that is for g for US customary unit is 32.2 now, and this is the acceleration for A. That is the unknown. Okay, so now we cannot solve for A and T. Now we require the additional equation to solve these two unknowns. Okay, so then we consider block B, the free body diagram of block B. Okay, free body diagram block B we may consider by cutting the system here. This may be better. Okay, we cut this block. Okay. When we cut this part, we can find out the free body diagram of block B is become like this. Okay, and from this case, on the left hand side is a free body diagram, on the right hand side is kinetic diagram, and we set up downward as a positive for this case, and for downward as a positive, we can find the equation of motion for y direction like this, that is equal to WB minus 2T equal to MB AB. And MB, the weight of block B is equal to 15, right? So for the mass is become 15 divided by G, that's G is equal to 32.2. And we have to unknown again, that is 15 minus 2T and AB, okay? But we have equation number 2 and equation number 3 that's have the we have two equations with two unknown T and AB. Okay, sorry. For number 2 is AA, right? Okay, but we know that from kinematics that we already solved. It is equation 1, that's AA equal to 2AB, right? That is moved to the right. Okay, so we use equation 1, equation 2, and equation 3 to solve these three equations with three unknown. Okay, but before that, we may check the impending motion for equation number 3. For the impending motion, what does it mean? It means that it's starting has a motion. That is, we may set up for the case that it is in static case. That is, AB is become 0 and it start moving. Okay, starting with AB is become 0 for that position. And we found out for that case, we have the tension become 7.5 pounds. That is greater than the static friction, the maximum static friction. What does it mean? It means that the tension inside of the cable is greater than the maximum static friction. So then the tension in the cable can pull the block, can pull block A to move to the right. Okay, so then block A will move to the right as we assume for the first case. And for this case, we solve for equation 1, 2, and 3. Okay, in details maybe like this. Okay, after that, after we solve these three equations, we obtain AB become 7.197 foot per square, and AA equal to 14.39 foot per square, and the tension is become 5.823 pounds. Okay, After we have this, okay, we would like to find the velocity of block A when it moves to the right with 1 foot. Okay, so for that case, we can apply the kinematic equation for the case of constant acceleration. A is constant. For this case, we see that acceleration of block A is constant. Okay, so then we can apply this formula. Okay, and from this formula, we substitute SA, that's move it with 1 foot from the problem given, and we found out the velocity of block A is become 5.365 foot per second. Okay, this is complete for the question number 1. And for the question number 2, that is we change, for the case that we change the weight of block A from 9 pounds to be 30 pounds. Okay, for this case, we found out the maximum static friction become 9 pounds now. Okay, the maximum static friction become 9 pounds. So when we check the impending motion again, we found out on that case, the tension is just from block B, it just has only 9.5 pounds. Okay, that is not enough to pull the block A to move. Okay, so it means that the tension in the cable is just only 7.5 pounds now, and it's less than the maximum static friction between block A and the floor, that is equal to 9 pounds. So then for this system, if we change block A to be 30 pounds, it has no motion. So if this has no motion, it means that the acceleration of block A and block B are equal to 0. Let's complete this problem.